y'all. Welcome back to Tater Talk. I'm Rachel.
And I'm Haley.
And in today's episode, we talk all about the potato varietal program with Tom Drader.
Yes. And again, as always, we have quite the bio for him. So we are so excited to talk to Tom. He's our director, like Rachel said, of global variety development and has been with Weston since 2015. Prior to his current role as that director, he was a principal agronomist and geneticist. So really smart things that
you'll hear a lot of that smart
yeah
verbiage throughout the whole episode.
It's really, really impressive, as with everybody else I think we've interviewed. But if you aren't sure what this job entails, like we didn't, this will be a really great episode. And it means Tom has helped develop potato varieties for Weston in North America, Asia, Australia, South America, Europe, everywhere we are, so that we can make the best premium fries in the world. And if that wasn't enough for you, Tom has his bachelor's in microbiology and a PhD in molecular genetics from Washington State University. So seriously, the person you want to be talking to about potato varietals.
Yeah. So we hope y'all enjoy this episode.
Yep.
Well, thank you, Tom, for joining us today. We're super excited to have you and talk all things varietal program.
Mm-hmm. Yeah, and I think yeah, it's gonna be good. And to kick us off, we always start really broad with like a big question, and so this is probably gonna be big. But can you highlight the foundations of our new varietal program? Maybe even with somebody in mind like myself who's never heard of it before.
Sure. So we have a potato variety development program that is global. So we support our entire enterprise around the globe. We work with I think it's 30 at this point, 30 different potato breeders, primarily focused in North America and Western Europe. But we do have a few others that are elsewhere. So we do have two major hubs, but we work with these potato breeders to basically find the right variety for our needs. And we define those needs based on what I call a lock and key system. So think of a lock like a padlock to a door or to a chest or something. We define that padlock as the needs that we have for the business in terms of growing conditions, the environment, the storage requirements, our finished product, what it looks like, tastes like, should behave as, and then also any of the major constraints that we have through the supply chain in order to produce that finished product. So that lock is the need. And then we find potato varieties with our breeders, our breeders around the globe that we call a key. And that key, some are going to be a better fit, some are not going to be the best fit, but you can imagine that many different keys could open that padlock, but some are going to be much better, much easier, more efficient at opening that padlock. So
that's such a good analogy. It's like it's really helpful to see that all come together.
Agreed.
Well, we actually had just talked to Steve not too long ago before you, and he had mentioned about, he was like, I'll talk about this, but you need to talk to Tom, you need to talk to Tom. He is the, the master of all this. But he mentioned some of these more like university and research partnerships that we have that go into like some of that rigorous testing of the new varietals. Can you talk a little bit more about that partnership that we have?
Yeah, so we do have, so in North America, it's primarily public breeding, so universities or government breeding, whether it's the USDA or Agri-Food Canada in Canada. In Europe, it's primarily private breeders, but we work with our public breeders in that same system I was just talking about, where we say, hey, here's our needs, here's our lock, and that they breed and select varieties within the environments, the Pacific Northwest, the Midwest, maybe Louisiana for sweet potatoes, or in Alberta, Canada as well, for our locks. And so they're working to find those varieties, and they bring them to us, and we have annual meetings where we're looking at over, I think globally, look at over 250 new candidates in any given year. Not all of those come into our program, and in fact, the vast majority fail. That they're like, it's not even worth it. So, but we work with them to find those varieties. We do have some smaller partnerships. I think more intimate partnerships where we do invest in the breeding with some of these universities, and so they would like the National Fry Processing Trials, where we contribute funds alongside some of our other industry members, where they take varieties from across the U.S. and place them in trials in the East Coast, in the Midwest, in the Pacific Northwest, and sometimes also in the southern U.S. To try to get an idea of which varieties behave the best, because most of those breeders are very localized. They only are breeding and selecting within Idaho. Their varieties don't get over to Maine, when Maine varieties don't get over into the Pacific Northwest until a much later stage. So we're looking at them earlier, trying to figure out which of these varieties and what germplasm can work the best, which allows them to breed better and more efficient potato varieties for all of us.
Yeah, I guess I wouldn't even think about that. Like, again, obviously, this is someone that doesn't, I only know much about ag from working here and talking to people like you, but oh yeah, okay, obviously, one that grew up in Maine or East Coast, like a variety that's used to there, it's going to act a lot differently when you bring it into the Pacific Northwest. So if we don't find that out until way later down the funnel, then it kind of has to restart that process. So it's
or we never even get them, right?
Yeah.
Sometimes they say it doesn't work for us here, and so they never send it out. And that's, we want to break some of that, because you look at, we deal with 30 breeders around the globe, 250 varieties. That's a lot in any given year, but really I'd like 1,000. I'd like 10,000, because that means that we can find the best of the best of the best for our growing regions. And if they're removing a lot of those because they don't work for their local system, then we'll never see them elsewhere.
Mm-hmm. Dang.
So you're saying 250 varieties. Is that like every year you see 250 new ones? Or are they just like small tweaks to existing varieties? I mean, this is
brand new. Yeah, with potatoes, they're not like, it's not like corn where you, or other types of maybe the grains and so on, where you're basically taking a starting variety and then you're crossing into it, and then you get a few more genes. With potatoes, and every time that you cross them, everything gets mixed up, and so you could take the same two parents that for a very successful variety, and we want to recover that variety again, and you cross it and get 1 million, 2 million, 10 million new seedlings. You'll probably never recover that original variety that you're really excited about. So every single time it scrambles up. The good thing with breeding is that as long as you find parent A that has most of the traits that you want, and parent B that also has those complementary, you're more likely to get the offspring to have what you want. And so you're just enriching the population every time that you combine those. But it is a very heavy resource demand to screen and select varieties in potatoes.
I'm just laughing. I'm thinking, I feel like I'm back in like biology class in middle school, where you have the matrix of like if you have this parent and this parent, like what are you going to get, green or blue eyes?
Yeah, Punnett squares, Mendelian genetics. Yeah, potatoes are much more complex than that, but yes,
it seems like
genetics.
it. Wild. There's only like 4 options that we can get with our old school, for us, potato.
Yeah.
Who knew potatoes were so much more complex than we are?
Yeah.
I love it. And I have to ask, I'm just more out of curiosity. And Rachel will laugh. I always ask a Haley question. So this is my Haley question. Is there a reason here that we do, our government is the one that controls the breeding program, or has most of that, versus overseas or in Europe where they have private breeders? Is there a reason for that?
There's not a specific reason. There's history that's allowed it to kind of funnel in that direction.
Okay.
Most breeding was originally government supported. Even in Europe, there was a lot of investment in just creating new cultivars, whether it's like set potatoes or other types of things, because it's a very costly process, and so it takes a lot of investment up front and a long time before you actually return anything. So historically, a lot of that was supported by government agencies. It's continued in the U.S. and a lot of the rest of the parts of the world where the universities and the government supports that. In Western Europe, a lot of that has been privatized.
Mm-hmm.
Oftentimes, a breeder or even any entity that says, I really need to have this very specific lock, you need to invest in it yourself rather than just relying on someone else to find it and select it. So there's a natural transition towards privatizing breeding, but over
Interesting.
a long time frame. Yeah. So
Yeah.
it's not required. There's no requirements in North America for it to be public. In fact, there are some private breeders as well, but they're very few. Yeah.
Gotcha. Interesting.
Cool.
Yeah. Um, I guess this might be a little bit of a transition, but it's still kind of on the realm of breeding. But can you talk about the benefits included in, like, finding these disease resistant, better yielding, less water reliant? I mean, we talk about heat tolerant, like all these different varietals. Like, what are all these benefits to finding these or doing all this research to ensure we have them?
Yeah. So I mean, that's a very broad question,
Yeah.
but I mean, just thinking about it again, our locks and our needs. Um, we need more productivity. So more potatoes per acre planted than we did 30, 40, 50 years ago. We still continue to have that demand. And with that, we've got shifting environments. We've got diseases that are evolving. I mean, potatoes or any crop gets viruses and fungal diseases and bacterial diseases just like humans do. And our flu shot evolves every year, so it's the same thing. Diseases evolve at the same rate as what we need to adjust to for humans as well. And so we're constantly trying to find disease resistance combinations that will help us reduce our dependence on management tools that we currently use in production. As I said, the environments shift, so we also are getting warmer days or cooler nights or less rain or more rain. And so having potato varieties that are more resilient and robust can help mitigate some of those unexpected changes in the environment.
Yeah. Does that contribute at all to some of our sustainability metrics too, just in regards of, having that crop's ability to be flexible?
Absolutely. I think the more tolerant they are to these changes means that we have to I won't say work less, but it's more about not requiring some of those management tools that we have relied on in the past. And so we don't have to apply a pesticide, or we don't have to support a weaker plant with extra fertility. That's going to help us with some of our ESG goals. And also, I mean, it's all about getting more yield for what we are applying. And so we're looking for varieties that are more efficient at capturing what we do apply and converting that into what we want. And that is the finished potato and eventually the finished product as well.
Awesome. Yeah, so it just is, it takes care of its own needs by itself in some of those ways, rather than having to add some of those other external things that we do to, stabilize or whatever's filling the blank.
Yeah, I mean, there's no potato variety that can do everything. It's just not
no perfect
realistic.
potato.
And so exactly. I mean, that's what we're striving for, but the reality is there's always going to be limitations. Superman was sensitive to kryptonite, right? It's the same thing. So finding a potato variety that is resistant to late blight, so that we may not have to apply fungicide sprays to control that. If we have a potato variety that no longer sprays in our finished product, we may not have to add sap in our processing facilities. So anything that is a limitation, we manage our potato crop and producing the finished product through all sorts of different mechanisms. But if we can alleviate that or mitigate it so that we don't have to do that, then that's a win. That reduces risk and allows us a more efficient process.
Oh, that's cool.
Yeah. I
Who
know.
knew?
Well, hope,
Every
I
time.
feel like you've achieved the dream of
But it's still a dream, right? So we're making little steps towards that, but we're not there to Superman, right? And even when we
Yeah.
get there, we have
Hey,
kryptonite out there. So
there you go. No, all really good stuff, and I feel like we could talk to you for obviously so much longer, but is there anything that's burning that you really want people to know before we depart today?
I think one thing just for everyone to recognize that this is, I'm on the screen, but there's so many people, both external and internal, that are doing a tremendous amount of work and just to try to make our finished products, right? We're looking at how do you make that better? What if you did this? What if you did that? There's a huge team that's supporting this whole system within Lamb Weston across the globe in all of our different sites, regional sites that are doing some tremendous work. And then there's also, like I said, a lot of people externally that both government, private, or contractors that are working really hard to find the best potato variety for all of our situations around the globe. So without naming all of them, obviously we don't have time, but I really want to recognize everybody that does a lot of really great work to deliver these potatoes for us.
We love that.
Yes, we love it. Love it so much. Ugh,
Mhm.
thank you so much, Tom. It was awesome to talk to you and just learn all the things about all the different potatoes. Again, I didn't know that they could be so complex just by marrying two potatoes. Like that one thing, that one analogy that you gave was, you gave a lot of good ones. We got Superman, we got Keys, we got the million little baby potato or
Sure.
the seeds.
Mhm.
So a lot of good nuggets for people to hold on to.
It's
Yeah.
great.
Thank you so much. This was awesome. Appreciate your time.
Yeah, thanks again.
That's all for today's episode. We want to thank Tom for talking with us. I was blown away by all of the genetics of a potato. Like, who would have thought? I had a breakdown in like my silly little brain
100%.
that it was like middle school biology for the Punnett squares. But I know it's so much more complex than that. But I was like, here's a tiny little example that I can relate of how the DNA, not the right terminology, of course, but for how that works for potato. But who knew like one seed can then change into 250 different varieties that we're always working with.
Yeah.
And so super cool to hear about all that and like the progress we're always trying to make sure we have potatoes.
Yeah, especially with, like you said, with climate resilience and all those things, how we get warmer days, colder nights, and ensuring that these potato varietals that we pick can withstand all those different changes so that we can always get these perfect fries. So how lucky we are to have Tom here at Lamb Weston. So yeah.
But that's all for today's episode.
Yep, and if you enjoyed this, make sure to share, and we'll see you next time on Tater Talk.
Bye.